Okay, sorry, I had to restart the video. So let's do number 1 again. Okay, so we're talking about simplifying radicals. Okay, and when we talk about simplifying radicals, the thing you're used to seeing is something like this. So if we see square root of 16, a lot of people know the square root of 16 is 4. Okay, so we know that the square root of 16 is 4. And the reason the square root of 16 is 4 is because if I was to break 16 down into 4 times 4, it has this pair of 4s inside. Okay, so when we talk about square roots, there's this understood 2 here. So if you see this radical sign without a number, you know it's a 2. Some of the other ones you'll see, if it's a different number, you'll actually see the 3 or a 4. So this would be like cube root. This would be 4th root. Okay, so a square root, they don't write the 2 because it's just an understood 2. So because we have this pair of 4s, and I want a pair because of this 2, I can pull out the 4. So if we were going the other way, we could say 4 squared is 16. And so what happens is this square is telling us that these cancel, and that's where we get that 16 from. Okay, so today we're going to look at ones that are not perfect squares that we need to simplify. So the first one on your paper is the square root of 28. Okay, so if I put square root of 28 in my calculator, well, first I'll put 16 so I show you it's a perfect square. Okay, so I just get 4. If I put 28 in my calculator, I get this weird decimal. So what we want to do is simplify it to where it's not a decimal, it's just a simplified radical. And the way you're going to do that is you're going to start with just a factor tree. So you're just going to list the factors of 28. So 4 times 7 is 28. Okay, you could do 2 times 14, whatever you know that multiplies to give you that number on the inside. And then we want to break down anything else. So I can break down this 4 into 2 times 2, and I can't break the 7 down at all, so that's it. So because I'm doing a square root, remember there's that understood 2 here, I want to look for a pair of numbers. So here I have this pair of 2s. That means if I circle a pair, that means I can take a 2 outside the square root. Okay, now notice I'm not bringing 2 2's out because these are still under the square root. So when I circle them, it's a pair, I can bring 1 on the outside, and this 7 is all by itself, doesn't have a pair, so it has to stay on the inside. Okay, so this, because I can't simplify the 7 anymore, this is my answer. And now, just like we put that square root of 28 in the calculator, we're going to put the answer that we got, 2 square root of 7, and we happen to get the same decimal so that we know it's the correct answer. Okay, so let's try another one on the notes here. We'll try number 2. Okay, so again, first thing, if you want to plug it in your calculator to see if it's a perfect square, go ahead. So square root of 256 equals 16. So I didn't get a decimal, I got a whole number, which means I'm done. So I don't have to do anything to number 2. Okay, let's do another one without a number in front and then we'll come back. So number 6, let's break 112 down. Now I don't really know what goes into 112, but I know it's an even number. So I'm going to see 112 divided by 2 is 56. So I know 2 times 56. Okay, and then I can break down the 56. I know 56 is 7 times 8. And I can't break down the 7, but I can break down the 8, 2 times 4. And I can break down the 4, 2 times 2. Okay, now remember, we're taking a square root, so we're looking for pairs. So I have a pair of 2's here. Okay, remember, that means I can bring out 1, 2. Then I want to look at the other numbers that are left. I've got a 2, a 7, and a 2. So I have another pair of 2's, which means I can bring out another 2, and it gets multiplied. Okay, this leftover 7 doesn't have a pair, so it has to stay on the inside. So if I simplify that, I get 4 square root of 7. And that is my answer. So let's check that. Put in square root of 112, and then put in 4 square root 7. We got the exact same answer, so we know it's correct. Okay, so just like how we multiplied these two numbers together, we're going to do the same if you have a number in front already. Okay, the problem is a lot of people forget this number. So in my answer, I'm going to go ahead and move this 2 into my answer so I don't forget it. Okay, and now let's break down 48. So I know 48 is 6 times 8, and 6 is 2 times 3, 8 is 2 times 4, and 4 is 2 times 2. Okay, so let's look at our pairs. I have a pair of 2's, so I can bring out a 2. I have another pair of 2's, so I can bring out another 2. And then I have this lonely 3 that has to stay on the inside. So we simplify that. 2 times 2 times 2 is 8 square root 3. Okay, so let's check that. If I put in the original 2 square root 48, and then I put in my answer 8 square root 3. Perfect. So we got the correct answer. Okay, let's do one more like that, number 4. So again, you have that number in front, a -3. Go ahead and put it in your answer so you don't forget it. And then let's break down 192. So again, I don't know what goes in 192, but I know it's even. So I'm going to divide it by 2, and I get 2 times 96. So then I can break down 96 is 2 times 48. You can break down 48 like we just did, 6 times 8. 6 is 2 times 3. 8 is 2 times 4. And I'm running out of room, but 4 is 2 times 2. Okay, so let's look at our pairs. I've got this pair of 2's down here, so I don't want to forget that. I'm going to put that up here. Then I've got a pair of 2's here. I have another pair of 2's. And then you want to make sure you've looked at all your prime numbers. Don't forget anything. There's this 3 here, so that's going to stay on the inside. So if I multiply that together, these numbers right here, I get -24 square root 3. Okay, let's check that in our calculator. So put in the original, -3 times square root of 192, and then put in your answer, -24 square root of 3. And we got the same answer. Okay, so let's look at one now with a little 3 in front. So let's look at number 8. Okay, so just like on the square roots, we had a 2, so we were looking for groups of 2. So I'm going to do the same process here, only because there's a 3 here, I'm going to look for groups of 3. Okay, so first thing, I see that 2, I want to put that in my answer. And then let's break up 64. So 64 is 8 times 8. If I was doing a square root, I have a pair of 8's, I could be done. But I need a group of 3. So I'm going to break 8 into 2 times 4. And then I'm going to break 4 into 2 times 2. So remember, you're looking for a group of 3 here. So I've got 2, 2, and 2, so that 2 can come out. And I've got another 2, 2, and 2, so that 2 can come out. So if I multiply those together, I get just 8. So let's check that in our calculator. I'm going to put in 2, and to find cube root, you press math, which is right here below alpha. So press math, and then it's number 4, and I want to put in 64. So see, I'm doing the cube root, and I got 8. And sure enough, that's what we got. Okay, so you're just checking your answer. So let's do another cube root one. Let's do number 14. Okay, so 14, there's no numbers to bring out front, so let's go ahead and break this down. 4 times 8 is 32. 4 is 2 times 2. 8 is 2 times 4, and 4 is 2 times 2. So again, we're looking for a group of 3. So I have 1, 2, 3. There's 3 2's that can come out. But then I have these 2 2's that are left over. They don't make a group of 3, so they have to stay on the inside of this cube root. And they get multiplied together. So my answer would be 2 cube roots of 4. And let's check that in our calculator. So I'm going to do math, number 4 to get the cube root of 32. and then I'm going to do 2 cube root of 4. And I got the same answer, so that means our answer is correct. Okay, so the last thing on this part of the notes we talked about is if you're taking the cube root of a negative, I just want you to bring that negative out front. Okay, and then I just want you to treat the cube root of 27 like normal. Okay, so if there's a negative on the inside, I want you just to bring it out. That way it's in the front and you don't have to worry about it anymore. Okay, so the second part of the note that we did was now we included variables. So if we look at number 2 here, I have this 5 in front. So again, if you have a number in front, go ahead and put that in your answer so you don't forget about it. Okay, so we're taking a square root here, which means, remember, we have that understood 2 right here. So I'm still looking for groups of 2. So when you have your x's or your y's or your a's or whatever variable you have, you could do this and write them all out. So x to the 6 means I have 6 x's, and I want to circle the pairs. So here's a pair of 2. That means I can bring an x out. Here's another pair of 2. That means I can bring the x out. And here's another pair of 2's. I can bring the x out. Notice there's no x's left, so my final answer would be 5x to the 3rd because I had 3 x's. Now, you can't check the variables, so you just have to make sure you do that carefully because your calculator won't show you that. Okay, I'm going to also show you a shortcut. Here, we had 6 x's was our exponent, and we were doing the square root. So if I do 6 divided by 2, I get 3. And that is the number that's going to be on the outside. Okay, or we could do it like this. How many times does 2 go into 6? 3. Okay, so let's look at number 3. The first thing I would do is, because there's this negative, I would go ahead and move it to the outside. Okay, and then let's break down 81. 81 is 9 times 9, and 9 is 3 times 3. Okay, so I'm looking for groups of 3 here because I have this cube root. So here's a group of 3, which means I can pull out a 3. And then I have this lonely 3 that's going to have to stay inside the cube root, which I'm going to run out of room, so I'll write it down here. Okay, so then let's look at our variables. We've got 6 A's, and I want groups of 3. So I'm going to show you the shortcut. How many times does 3 go into 6? Would be 2. That means I can have 2 A's on the outside of the radical. Okay, so that was the A's. If I look at the B's, I have B cubed. How many times does 3 go into 3? Is just once. That means I have 1 B on the outside of the radical. Then I look at the C's. How many times does 3 go into 5? Well, now this one's not going to be perfect. 3 goes in once, so that means this tells me how many C's are going to be on the outside. And then when I multiply that and subtract, I get a remainder of 2. That tells me how many C's are left on the inside. Now, my answer is kind of messy here, so let's simplify this. Negative 1 times 3, so negative 3. A squared BC, and then I have the cube root of 3C squared. And that is our answer. Okay, let's do another one because I know it's kind of a tricky subject. We'll look at number 5 with just one variable. So first thing I would do is pull this negative onto the outside. And then let's simplify that 27. So 27 is 3 times 9. 9 is 3 times 3. I'm doing a cube root, so I'm looking for a group of 3's. There's a group of 3. So I put times 3. Okay, then I have 7 x's. So I have 7 x's, and I'm doing cube root. So I say, how many times does 3 go into 7? 3 goes into 7 2 times, which means I can bring 2 x's on the outside. And then when I do the remainder, 2 times 3 is 6, I get 1. That tells me how many is left on the inside. Okay, so this tells you the outside number, and this tells you the inside number. So my answer then would be negative 3 x squared cube root of x. Okay, number 7 is the same thing, and number 7 and number 8. It's just that now they're giving you the two pieces. So they're giving you a 3x together. If you just treat it as one whole thing, we're doing groups of 3, or sorry, it's square root, so we're doing a group of 2. So just like we did before, how many times does 2 go into 3 is once. That means I can bring a 3x on the outside, and then my remainder is 1, so that means I have a 3x left on the inside. Okay, now let me show you that one a different way as well. I have 3 of these, okay, because it was 3x cubed, so I have 3 of them, and I want a group of 2. There's a group of 2. That means I can pull 1 on the outside, but I have this one left. It has to stay on the inside. Okay, so number 8, the shortcut again is how many times does 3 go into 6? Twice. There's no remainder, so that means my answer is just 2x minus 7 squared.